All right, greetings, fellow grade 11s. It is still your favorite tutor, Mr. Shajayo, and welcome to Back to Basics. In the diagram below, you're having two circles that touches each other externally, right? You're also having QPR, which is a common tangent, right? So they are saying QPR, this, which is highlighted, it is a common tangent for both circles. And then what else now that we know? We know that also EDCR, right? Where is EDCR? So this one is the tangent from this smaller circle, right? And now you are given that you are having what? You are having your RCA, which is Y here, right? So you are given here your RCA, which is going to give you your Y rather, and you're also given your X here, right? So these are the two things that you are given here. So there, we are also told that your AD is parallel to what? Parallel to BC. Now, what is the first thing that you're going to do now from here? They want us to give four angles that are going to be equal to X, right? So which are the four angles, firstly, that are going to be equal to X, right? Now, what is what is going to be the first one, which I'm going to mention here? I want us to look at this carefully, right? Let me just start here. Now, since this is a parallel line, right? So can you see that I can start by saying my angle C2, right? My angle C2 is going to be same as what? This is going to be same as X, right? Because if I start from here, right? If I start from here, I come back here, right? And then I go back there, right? Surely you can see that these two angles are alternating, right? So which means C2 is equal to X. These are alternating angles. Why are these angles alternating? Because your AD is parallel to what? To BC, right? So which means here I'm going to write that this is X. Are we all fine, right? So basically that is going to be the first angle that is going to be equal to X. Which other angle now is going to be equal to X? I want us to look at this, right? Can you see that I can also say your P6, right? P6, since this is a tangent, can you see that P6, it's an angle for what? Now P6, this is tan chord, right? Or rather, I think this is not necessarily P6, but P5, right? Can you see that your angle P5 here, right? So if you're looking at P5 is going to be close to X. Can you see that one, right? Because of tan chord theorem, right? If you look at this angle in the triangle here, you'll realize that your angle P5, right? Your angle P5 is going to be close to X. This is because of tan chord theorem, right? So remember your P5 is equal to C2, right? Your P5 is equal to C2, and our C2, we've already proven that it's X. So that's why this is also going to be equal to X. Are we all fine, right? So basically now that's going to be that one. And again, now this side, can you see that this side actually now, this side here, which you are having your P1, right? Your angle P1, right? So we found that this is X. Your angle P1 is also going to be equal to X. This is because of tan chord theorem also, right? This is tan chord theorem, right? So this is tan chord theorem. So which means now from here, this is also going to be X because remember your your QPR rather is given by what? So this is going to be what? This is going to be your tan chord. Altogether, right? If you're looking at this second, right? Can you see that this angle here up until here, just only up until here, and also this one from here up until here, right? Can you see that these two, they are forming a bow tie, right? Which means here is going to be equal to X, right? Because these are angles in the same segment. Your segment, what? This is segment DP, right? So which means also your angle E there at the corner, right? The angle E there at the corner is going to be also equal to X. Why? This is going to be same as what? This is going to be same as angle in the same segment. All together, right? So basically now that's going to be that one, right? I want us to look at 12.2. So in 12.2, they want us to show that EPA is X plus Y, right? So what is the first thing that you're going to do now from here? Look, I want us to understand. Remember, we've already proven that your angle C2 is given by what? It's given by It's given by x, right? So I want you to do this, right? Can I not conclude that my angle C, right? So the entire angle C, right? The entire angle C is going to be same as what? The entire angle C is going to be same as the entire angle what? This is entire angle D, right? And why am I saying that? Why am I saying your angle C is equal to angle D? Let's just bring this back. So this, we are saying this is equal to each other because these are corresponding angle, right? These are going to be corresponding angle. And why are these angle corresponding? Because your BC is parallel to what? Is parallel to 80. Can you see that one, right? So this angle here is corresponding to this particular angle, right? So which means, for example, I am going to say this is actually not angle D, but it's D1, right? So my angle D1 is equal to angle C. These are going to be corresponding angle because BC is parallel to 80. Secondly, now I can now say, look, if my angle D1 now is going to be same as X plus Y, is that correct? Yes, that's correct, right? Now, so if I am looking at my EPA, where is my EPA? This is E, this is P, this is A, which means actually this is same as angle P7, right? So my angle EPA is going to be same as angle D1, right? Can you see that these angles are going to be equal to each other, right? Because these are angles in the same arc, right? These are same angles in the same arc, right? Remember, they are subtended by this same arc. Are we together, right? So these angles are going to be angles in the same arc, which means now your EP, or rather your EP, not this one, your EPA is going to be given by what? This is going to be given by X plus Y now, because we've already proven that this is given by what? This is X plus Y. Are we together, right? So basically now that's what you are going to have in this particular question, right? So basically now, now that's what you're going to have as 12.2. Let's move swiftly along and look at your 12.3. Determine the numerical value of x plus y if you are given that your DCTP is a cyclic quadrilateral, right? So let me highlight this one firstly. Your this is P, this is T, right? I want just to highlight the cyclic quadrilateral first, right? Now this is what they gave us as a cyclic quadrilateral. I want us to see in terms of what is it that we can do now from here to determine this, right? Now, firstly, so they are saying here, they want us to determine that this is going to be a cyclic quadrilateral, right? So we are going to start by saying now, firstly here, can we not agree that your angle what? Your angle B2, right? Your angle B2 is going to be cos what? Your angle B2 is going to be cos Y, right? Can you see that your angle B2 is going to be cos Y? And why am I saying that? This is because of what? This is going to be tan this is going to what? This is going to be tan chord theorem, right? Can you see this is tan chord theorem, right? Yes. So which means now from here, your angle B2 is going to be same as what? Your angle B2 is going to be same as Y. This is going to be tan chord theorem, right? So this is going to be because of tan chord theorem, right? So which means this entire angle here is going to be Y, right? And if that angle is Y, then I can also make a conclusion that my angle P2, is also going to be equals to what? Can you see that my angle P2 is going to be also equals to Y, right? Why am I saying that? This is also because of tan chord theorem, right? This is tan chord theorem, right? So basically that's why we are going to have this as your Y. And now, which means now from here, this is going to be given by what? This is going to be given by Y. How to get, right? Now, I want you to look at this, right? So now, for example, I am also going to say, look, my angle what? My angle P2, right? If I can say my angle P3, can you see that my angle P3 here, right? My angle P3, right? If you look at this side, right? Let me just show you this. See this side and also this one here, right? And also this line here, right? So can you see that this angle here? right? Or rather my angle P3. So to find out what is going to my angle P3, now I'm going to realize that my angle P3 is going to be same as what? Your angle P3 is going to be same as X plus Y. And why is my angle P3 going to be equal to X plus Y? Right? Let's see that. Now, uh, I know maybe we want to find out what is going to my angle P3 going to be equal to X plus Y. Now, let's see here firstly, right? So can you see this? Can you see that this line here, right? Can you see that this is vertically opposite to this angle, right? So which means actually your angle P3, I was drawing a wrong line there. So your angle P3 is going to be X plus your Y. This is because of vertically opposite angles, right? This angle over here is the same as this angle over here, right? So which means now your P3 is going to be same as X plus Y. And after that, what else then now I am going to have here as your angle P3? Now I'm going to come back and say, look, now I found that my angle P3 is X plus Y. Now I'm going to come back and say, look, now I want to find out my numerical value of X plus Y. Right? So here I have this is X. Remember, this is now given by what? This is X plus Y. Now, I want us to look at the opposite angles of a cyclic quadrilateral, right? So can I not conclude that my angle DPT, right? The entire angle here, DPT, because this is a cyclic quad, DPT plus my angle C, it's going to give me 108 degrees, right? Because these are going to what? These are opposite angles of your cyclic quad, right? This is opposite angle of your cyclic quad, right? This is cyclic quad. Are you fine, right? So which means now from here, what is going to my angle D, for example, my angle P1, P2, P3, and P4, right? Remember, DPT consists of P1 plus P2 plus P3 plus C1 plus what? This is plus C2, which is equals to 108 degrees. Now, what is this going to be, right? So which means it's actually what? This is same as X plus Y, right? This is plus X plus Y plus this is going to be same as what is this angle here? This is also X plus Y is equals to 180 degrees, right? And what will this be? Now, from here, let's see. So now from here, can you see that here we are going to have x, we are going to have 3x plus 3y, which is equals to 180 degrees, right? So which means now from here, can you see that your x plus y, taking out 3 as a common factor, is going to be same as 108 degrees. Now we divide by 3, right? And when you say x plus y divided by 3, this is going to be same as what? Your x plus y is going to be given by 60 degrees. Are you fine, right? So which means this entire angle here is going to be given by 60 degrees, right? So basically, this is how we go about whenever we are required to prove a question, right? So hopefully all of this makes sense. And thank you very much for listening.